video on Blackboard tonight. Okay, how many people own an electric vehicle or know someone that owns an electric vehicle? Well, whether you know somebody or not, or you own one or not, these electric vehicles are heavily subsidized by government. Now, anybody know the average price of an electric vehicle, roughly? It's about $60,000 for an electric vehicle, roughly on average, about $60,000. I can't afford to buy an electric vehicle. I can't, right? And I don't know if I want to, because if the battery goes out, replacing the battery is like an additional $20,000. Plus, I've heard if I buy an electric vehicle, I'd want to be able to plug it in at my house. And I've heard those electric vehicle terminals cost $10,000. So that's a lot of money, right? I have the car I drive around right now. I bought it for cash for $2,500. It gets 35 miles a gallon, right? I own a clear title. So I'm not in the market for buying a car, right? I don't want an $800 a month or $600 a month, a $500 a month car payment, right? So I've chosen not to buy new vehicles, right? So they're really expensive. I consider them expensive. Who can afford them? Well, rich people do, right? So if you watch this video, there's some inconvenient facts about electric vehicles that people aren't allowed to talk about. John Stossel, by the way, was a consumer advocate. He was a progressive in the 1960s and 70s. And then something happened. He was covering a story and it flipped him. He ended up becoming a libertarian. And I would consider myself a libertarian. Okay, so according to this article, electric vehicles comprise about what percent of the market? Let me do this. I don't want to go through the article, but you can read the article. I'm going to go back here. Might be better to read the article. Okay. So electric vehicle, according to this article, about 2% of car sales. Electric vehicles are about 2% of car sales. The article also indicates that 322,000 electric vehicles were sold in 2020. And the average cost is, I'm going to put them over here. Put these numbers over here. The average cost is $56,437. That's the average cost. So just under $60,000. Okay. We can go through that, but I don't want to go through the. If you guys are interested, you can read the articles. So this is 2%. The average is 56,437, and then 322,000 vehicles were sold in America in 2020. Right. Yeah. The inspiration for this model came from the fact that when we came out of the pandemic, if you guys remember, there were no computer chips, right? There were no computer chips. And so what that did is it put a physical constraint on the number of vehicles that can be made in a given period of time. And what that does is it kinks the supply curve. It kinks the supply curve. So the supply curve is two parts. This right here is the upward sloping part. And this right here, the vertical part, is the supply constraint, right? When demand is really, really high relative to the supply, there's only so much capacity, right? So once you hit that capacity constraint, the supply curve goes vertical because you can't make any more, right? You can't make any more cars. And that was one of the contributing factors to used cars and new car prices skyrocketing just after the pandemic. So we have a two-part supply curve. The supply curve kinks when the economy is growing and unemployment interest rates are low because only so many cars can be built in existing factories over the short run, right? Mm-hmm. We're going to use Desmos to find the initial equilibrium, right? We're going to find Desmos to find the initial equilibrium. So we're going to click on Desmos. And notice the supply curve goes vertical, right? I'll move it over to the left. And what you have to do is you have to match up the numbers, right? So my demand curve is that. Actually, all you got to do is copy the intercept. There's my demand curve. And then this is 323. And then the supply curve. We got to connect those lines there. I thought I'd use the same supply curve for everybody, but I guess not. Okay, then we got to connect. So we have to do is we have to lower this value here. Lower that down to 30,000. There you go. All right, we got it. So this 323, your quantity goes here and here, right? And then these values go here, right? And then these two values go here and here, right? I guess I'm gonna do the subsidy down here. Okay. And then you got to adjust this right here. How do I adjust that? Well, that was like what, 46,000 is up here. What I did is I just looked at the height here. Height is about 30,000, right? So I'm looking on this part here. The height is about 30,000. So that's why I changed this to roughly 30,000. It doesn't have to be exact. That's enough to make it connect the upward sloping part of the supply curve with the vertical part, right? All right, any questions on that? Everybody got it? If you need help with this, you can buzz me and I can give you help on it. Right? Everybody's got their Desmos looking like the one in the problem. We're all good? All right. Okay, so the number of EVs supplied at this point, this is the equilibrium here, right? Does everybody understand why supply kinks here? Only so many cars can be built in the existing factories over the short run. So there's a constraint here, right? Which causes the supply curve to go vertical, right? And this was the issue. This is one of the issues following the pandemic, right? We had supply chain interruptions everywhere. So my equilibrium quantity, this quantity here, is just this quantity here, right? We're at that supply constraint, right? People are ordering electric vehicles and they got to wait 4 months to get them because they can only make so many electric vehicles in a given period of time, right? When I substitute that in the demand curve, again, I want to substitute that in the demand curve, right? So I'm going to put a times here. I'm going to do 323, 1, 2, 3, right? And my price is $60,000. $60,000. No comma. Right? You can tell that makes sense, right? 60,000. Right? So I'm going to change this back to Q. I'm going to change that back to Q. Now it says indicate the areas in the graph that represent consumer surplus. Well, consumer surplus is the triangle that is above this gray line here that I'm moving across, right? This here is consumer surplus, this triangle, right? And that
Mr.
is equal
Snore.
to 3.13, right? That's the consumer surplus, right? The firm surplus is the trapezoid below it, right? So along this line, down this line, down the upward sloping part of the supply curve, and then up the y-axis, right? This lower trapezoid is the firm surplus, which is a big number, right? 11.129 billion. Consumer surplus is this little triangle at the top, right? The little right triangle at the top here. That's consumer surplus.
Mr. Snore.
Yeah.
I don't think mine is set up the same way yours is.
Can you share your screen with me?
Okay. Like I said, mine is on my laptop, so I can share a video with this, and then I'll just like show you my laptop screen.
Okay, that's fine.
I don't know if I can flip my camera.
Well, you can rotate it the other way. You can rotate it 180. There you go. Oh, yeah. What you can do is approximately what height is where that upward sloping line and the vertical line meet? What height is that approximately?
I think it's like 55,000.
Yeah, just change it to 55. Yeah, see what happens. Oh, 30, 35.
Okay.
That's good enough. Yeah, that's good enough. Yeah. You're
Okay.
fine. Yeah.
Okay.
It's not all that important in Desmos. I was having fun with this two-part supply curve. So it's not a big deal, but it's not exactly right. It's close enough, right? Okay, so now suppose the federal government passes a law that gives each consumer a subsidy, right, to purchase an EV. This would do what? If you're given a subsidy, what's going to happen to your demand curve? Your demand curve is going to shift up, right? So what I'm going to do is I'm going to add. I'm going to click right here. I'm going to put plus right in front of that curve, in front of that intercept, when that's identical to this one up here. I'm going to type my subsidy right here. I'm going to turn on line. See, I turned on the line. So this right here is the subsidy that's in the problem. Mine's 9,300, right? Mine's 9,300 here. So basically I have the original demand curve here, and then adding to it a subsidy, which shifts the demand curve up, right? If I know that I can go into a dealership and the government's going to cover $9,300 of that price, it's going to shift my demand curve up by the amount of the subsidy, right? So this would shift the demand curve upward by $9,300.
Can you do that?
I get the same thing up here, right? See, I get the same looking graph over here. Questions?
Can you do the where you got 60,000? Can you do that again? Because since my graph was messed up.
Oh, yeah. Right up here on your original demand curve, type in your quantity. It's given to you in Desmos right here.
Okay, I typed that in, and it's saying my number is wrong.
Okay, are your numbers matching up right here? 7-9, mine match up, right? See that? Mine match up to this original problem right there.
I think I put it in 0.06 because you put in 0.06.
Okay, yeah, you gotta match yours to your demand curve, right?
I'm gonna switch that.
Yeah, and then you want to put a times in between the slope, which is negative, right? And the Q. And then all you gotta do is delete the Q and then type in the quantity right here, right?
Okay.
And you should get the right number.
Okay. Thank you.
The right number?
Yeah.
Okay, cool. Okay, so what happens to our supply curve? The slope is the same, right? This is a minus sign here. That's a minus sign. So our slope is minus 0.06, right? It's my intercept. Well, what I'm gonna do is I'm gonna copy the old intercept plus a subsidy down here, right? So my new intercept is this value. It's the old intercept plus the subsidy, right? It's plus that subsidy. So I'm just adding the subsidy to my intercept, right? Of my demand curve. You see that? Just adding the two. Adding that intercept to the subsidy. And that gives me my new intercept, right? You got everything else? You're good?
Yep.
Okay. Now, after the subsidy is enacted, the equilibrium price equals what? Well, what I'll do now is, notice the quantity hasn't changed, right? You can also get it from Desmos right here, right? So I can click on that. That gives me my original price. And this gives me my new price. Now, notice the new price. The new price is just the 6,000 plus the subsidy, right? You have the original price of $60,000 per electric vehicle plus subsidy. Well, that's odd, right? Right? Isn't that kind of odd? It's kind of a game, right? It's kind of a game. The quantity is still whatever it was, right? The quantity is still that, because there's only so many electric vehicles can be produced at our current level of capacity in the short run, right? That hasn't changed. Now, the lowest price EV manufacturers were willing to accept to make these cars is down here, right? To do that, I'm going to do this. I'm going to copy the supply curve. I'm going to copy this part of the supply curve here, right? Copying that. So this is the right-hand side of the supply curve. I'm going to multiply that by the 323,000. You see that? So I can click on the supply curve here, and I can read it off the graph, right? 323,000 EVs made. The lowest price the firm is willing to accept to make that quantity, in my case, is 30,390, right? And I get that by taking this part of the supply curve and multiplying by Q, right? So this is, in my case, 30,390. So all I'm doing is I'm basically just I'm plugging this value into here. That's all I'm doing, right? So if you go to your original setup of the problem, the green supply curve, you just take that quantity, whatever it is, multiply it by your slope, in my case, 0.03, you add that to the intercept, 20,700, right? So you just plug this value into here, right? And you can do that in Desmos right here, right? That's all I'm doing in Desmos, right? Okay. Indicate the area in the graph that represents the new firm surplus. Well, the new firm surplus is from this point here, straight over to the vertical axis. It's now the trapezoid that's below this purple mouse pointer down to the upward sloping part of the supply curve. It's gotten bigger, hasn't it? The consumer surplus is the triangle that's above that point. So it's the triangle above that point. The consumer surplus has not changed at all, right? It was 3.13 billion. It is 3.13 billion. The firm surplus went from 11.129 billion to 14.133 billion, right? So why do we want to subsidize electric vehicles? Because electric vehicles are supposedly better for the environment, right? So we subsidize, we want less pollution. So if you want less automobile pollution, you can tax the crap out of cars and you subsidize the better version of the car, the electric vehicle, right? So you can subsidize the car. So here you could think of electric vehicles as being kind of a positive externality, right? There's no carbon emissions coming from their tailpipe. But that ignores the carbon emissions that were used in the mining of rare earth metals, the transportation of those rare earth metals, right? It ignores all that. But we want to subsidize good things, things that are good for the environment, and we want to tax things that are bad for the environment, cigarettes. So we're subsidizing electric vehicles and we're taxing cigarettes, right? The subsidy has many effects. The increase in consumer surplus is $0 billion. It didn't change, right? It was 3.13 billion. It is 3.13 billion. The increase in firm surplus, well, firm surplus was the area of a smaller trapezoid. I'm going to copy that and paste it right here. It's what firm surplus was, right? Firm surplus was the trapezoid that is below 60,000 in my model, right? Now the new firm surplus is this bigger trapezoid that goes from basically 70,000 all the way down to the supply curve, right? And the new firm surplus is $14.133 billion. Oops. I'm going to subtract the two over here in Desmos. The firm surplus increased by $3.04 billion. This is why Elon Musk is really rich. Why he's a billionaire. It has something to do with it, right? Because the purchase of his vehicles were, or maybe even are still subsidized by government, right? The increase in total surplus comes from firm surplus, right? Just add the two together. Since this is zero, we'd add these two together, but since that's zero, it's just the increase in firm surplus, right? And surplus is just the benefits that accrue when consumers and firms voluntarily engage in commerce, right? Now, what's the cost of the subsidy? How much was the subsidy? The subsidy was $9,300, right? Or $9,300 per vehicle. $9,300 per vehicle. How many vehicles were sold? 323 in my case, right? So this value is the value that was given to me up here, right? Somebody were sold before and after the subsidy. My subsidy is $9,300. So I'm just multiplying them together, right? And I might have to do this in Excel. Hang on a second. There might be too much rounding off here. I'm going to copy these two numbers into Excel. Oh, that's a times. And let me blow that up. Okay, so I have my subsidy and the quantity I was given before and after the subsidy, right? Now I want to change this to numbers and comma. 70 billions of dollars. Oh, guess what? That's the amount of the increase in firm surplus. You see that? That right there in billions, right? $3.004 billion. Well, these are all the same number, right? So the subsidy goes to whom? The rich billionaire that owns the electric vehicle company, right? This is perhaps why this might be the reason why the green economy is so desired, because the owners of these green companies are probably going to get most of all the subsidy that government is giving them, right? It's not going to really go to the consumer. It's going to go to the firms, right? Like Elon Musk. The deadweight loss here is 0, right? There's no triangle here. There's no triangle. There's no deadweight loss triangle here, right? Because the quantity before and after, is the same. So there's no deadweight loss here. So all of the benefits of the subsidy accrues to wealthy EV buyers? No, they just pay a higher price. The subsidy just means they pay a higher price out of pocket. Poor EV buyers? No, because they don't buy EVs before or after the subsidy. Middle income EV buyers? No, because they don't buy EVs before or after the subsidy. It's the EV manufacturers. Okay. 100%, right? How'd you do, Chase?
When I messed up that first number, I didn't get some of them. So that I was just about to ask you, like, when are you going to post this? Because I just got to go back and make sure some
I
of my
gotta redo
numbers
it.
are.
I'm gonna post it as soon as I get done with class.
Okay, so it'll be up by like 6, like you said.
I'm hoping it takes a while for 2 videos to process on Zoom.
Oh, okay.
Once they're processed on Zoom, then I'll be able to upload them pretty quick to my YouTube channel, and then while YouTube is processing it, I'll create the video pages that you see in Blackboard.
Okay.
Yeah. So the longest part is Zoom processing the video.
Okay. Thank you.
Okay, cool. Awesome. Well, have a good night.